Now, where is that second equation going to come from? We used the y forces. Are there any x forces on the diving board? No, there are no forces in the x direction. So now what we need to do is take the torques of all these forces about any convenient point. Means about any convenient axis that passes through any of these points, A, B, C, or D. Now tell me, which of these points is convenient for us? What is the definition of convenience I gave you? The most convenient point about which you can take the torque of the forces is the point through which maximum number of unknown forces pass through. Now here, A is a good point because R1 passes through A. That means the torque of R1 about A will be 0. B is also a convenient point because an unknown force R2 passes through B. Now we will choose A. I have chosen A, but you can do it by choosing B. Let's take the torque of R1. What is the torque of R1 about an axis that passes through A? Since R1 passes through A, the torque arm is 0. Therefore, the torque of R1 about A is 0. What is the torque of R2 about A? Remember, torque is the torque arm multiplied by the force. What is the torque arm here for the force R2? The distance between A and B is 1 meter. So that will be 1 meter multiplied by R2. That is the torque of R2 about an axis that passes through A, and that will simply be R2. Tell me, is that a clockwise torque or a counterclockwise torque? Have you figured out how to do this now? We are rotating the object about an axis through A. So point there and then draw a circle with the force like this. R2 rotates about this point counterclockwise. Therefore it is positive. R2 is positive because that torque is a counterclockwise torque. The torque of 245 Newton. Tell me, what is the torque of this 245 Newton about A? It will be, the torque arm is 1.5 meter multiplied by 245, and that is 365.5. It is negative because that torque is a clockwise torque. Watch me trace out. It is a clockwise torque. So it is negative. What is the torque of 784 Newton about A? It will be, the torque arm is 3 meter multiplied by 784. That is negative 2,352 meter Newton. Why negative? Because that torque also is clockwise. Therefore, it is negative. There you are. And now, let's add all these torques. The sum of all these torques, what will that be? 0 plus R2 minus 367.5 minus 2,352 must be equal to 0. So, R2 minus 367.5 minus 2,352 equal to 0. And that gives you R2 equal to 2,719.5 Newton. So the reaction force on the second support is 2,719.5 Newton. Once you know R2, we can go to equation 1 and solve for R1. Let's do that. Using the value of R2 in this equation, R1 plus R2 equal to 1029, we get R1 equal to 1029 minus R2, and that R2 is 2719, and that gives you a negative value for R1. R1 is negative 1619.5. Now, what does that mean? What does it indicate that R1 is negative? You see, we assumed that the reaction force on this outer support is upward, but really no. You see, when this man is standing here, this force is trying to rip apart the diving board. Therefore, the duty of this support is to hold it down. The reaction force of this support is not upward but downward. Now you notice that even if you make a mistake, the method of the problem will correct us. So it doesn't matter if you assign a force in the wrong direction. If you use the correct method for solving the problem, the method of the problem will correct you. So what is the value of R1 now? R1 is 1690.5 Newton directed downward. Okay, let's go and solve another problem. An 18 Newton weight is supported